Hello guys, welcome back. In this video, we will start with a new section that is derivatives. So let us first have a basic introduction. What exactly a derivative is? A derivative is instantaneous rate of change of a quantity. So in mathematical terms, we can say it is the amount by which a function changes at a particular point. So let's first make it a little more clear with a basic example. So we are taking example of let's say there is a function dependent on time, and this function is giving us the the function is giving us the distance traveled, which is dependent on time, right? So this is giving us this distance traveled with respect to, or we can say uh, it is distance traveled as a function of time, right? So let us take a basic graph. Let's say this is the function. Let's say this is f of t, right? And this is the distance traveled, that is s, and this is the input parameter, that is t. So now we have to compute instantaneous rate of change of distance with respect to time at a particular point. So let's say the point is this one, a, right? So we have to compute the derivative of this s, this function, let's say, which is distance traveled with respect to time. So how we will compute? So the rate of change of this function will be given as, let's say, this is the first point. So this is the point at which we are calculating the rate of change. And let's say there is a very small change, infinitesimal change in considering the next point. Let's say this is the next point. And this coordinate is x coordinate is a plus h. And if this is a, this will be f of a, and if this is a plus h, this will be f of a plus h, right? And since it is instantaneous rate of change means this change is in the input parameter is very small. So this h is actually very close to 0, so it approaches to 0. So now let's try to write it mathematically. How we will write the derivative of this function with respect to time mathematically? So let's write that. So we can say derivative of the function f of t at a point t equal to a, so that will be equal to the rate of change, that is nothing but the change in the distance traveled, that is f of a plus h minus f of a over change in the input parameter, that is time. So that will be a plus h minus a. So this a gets cancelled with this a, and this remains as f of a plus h minus f of a over h. And since we were considering h very close to 0, so now the concept of limit also will come into the picture. So we will say h is tending to 0. So we will write this as the limit h approaches to 0, f of a plus h minus f of a over h. So this is the derivative of f of t at t is equal to a. Also, there is one more way of denoting the derivative mathematically, that is f prime t. So this is the point, this is at the point t equal to a. So this is a mathematical way of writing a derivative. So this is the derivative of this function f of t at t is equal to a, right? So also this limit here should always exist in order for this derivative to exist, right? So this is the main consideration, or we can say this is the basic formula of computing the derivative of f of t. So this thing is what we introduce as a basic definition of computing the derivative. So let us take a simple example. So our example is that we have to find the derivative of a function. Let us say f of x. We have to find derivative of function f of x is equal to x square plus 1 at a point x equal to 3. So remember here, when we calculate derivative, we calculate at a point. So this point is x equal to 3 here, right? So now, as we discussed few moments ago, the basic definition of how to compute the derivative. Let's abide by that definition only, and let us compute the derivative of this function at this particular point. So let's go ahead with this. So we will write the derivative of f of x at x equal to 3. This notation was f prime x at x equal to 3, or we can write it as f prime 3 also. So this is a more shortened version of writing this. So we can write f prime 3, which will be equal to limit h approaches to 0. So we are taking an interval which is very close to 0. So that will be limit h approaches to 0. F of a plus h, f of a plus h, a here is 3. So it is f of, that will be minus f of 3, right, over a plus h minus a. That will be h, right? So how we will compute f of 3 plus h? F of 3 plus h we can compute by directly plugging in 3 plus h into this function. So that will be limit h approaches to 0, 3 plus h whole squared plus 1 minus f of 3, that is 3 squared plus 1. And this h will remain the same. So now let's open this 3 plus h whole square. So that will be h square plus 9 plus 2ab, that is 6h plus 1 minus 9 minus 1, and this one gets cancelled with this one, and it is h. So this 9 also gets cancelled with this 9. Okay, so and here h is coming out common. Okay, so we will take out h as a factor here, and since h is not equal to 0, it is approaching to 0, so we can cancel out one h from both numerator and the denominator, and the remaining is limit h approaches to 0, h plus 6. Okay, so and since h is approaching to 0, we can plug in h as 0 here, and the answer will be 0 plus 6. So this will be 6. So what is this 6 now? This quantity 6 is the derivative of this function at x equal to 3, or we can say the rate of change of this function f of x with respect to x at this particular point x is equal to 3, that is 6. So this is our answer. So this was it for this video. Do join me in the remaining derivative videos. Bye bye.